When you're given an inverse function, like f of x equals 3x minus 5, you want to be able to solve for the function for its inverse. So we have a couple steps first. What I would encourage you to do is graph it. So I'll hold on to that, off that for a second. So the first thing you're going to do is you're actually just going to replace the f of x with y. It's easier to work with x and y than f of x. So what I would suggest you doing is graph y equals 3x minus 5. Just get a visual for where that looks like. Go into Desmos and see that a lot of times it's a line or a quadratic or something like that. So you can see what that looks like. The next thing is you're going to replace the x with the y. So you're going to literally switch the x and the y in your function. If there's more than one x, make all of them y, but usually we just switch those guys there. And as you're going through, you can see what the inverse looks like. You can literally type in x equals 3y minus 5. And so you can see that inverse function there. And I'll talk about some patterns you'll recognize when you graph them later. So after you do that, so after you replace f of x with y if necessary, and you switch x and y, your last step is to solve for y. So let's go through that process. So in this case here, we want to get the y by itself. So we're going to add 5 to both sides. And it's going to cancel that out. So that's going to be x plus 5 equals 3y. Now, one thing you can do as you're solving, just to make sure you're doing the right steps, is you can go into your graph and you can type in each step. So you can say x plus 5 equals 3y. And you notice how these two graphs, let me hide this one for a second. You notice how the x equals 3y minus 5 and the x plus 5 equals 3y, those are the same line. So you know you did the step right if you overlap them. So let's do the next step. For this one, we want to solve for y, so we're going to have to divide both sides by 3. I prefer to divide the whole side by 3, not you can do x divided by 3 plus 5 divided by 3. Just it's easier to do that. So you would, let me rewrite that here. X plus 5 all over 3 is equal to y. And again, I'd encourage you to go through and enter that step into Desmos. So you do the fraction bar, x plus 5, go down and put the 3 equals y. And again, we know we did that right because that line overlaps it. So these three are all the same thing. But now you got that solved for y. So the last step is to just rewrite it in notation. So you would say f inverse, because remember inverse is that little -1 notation. X equals x plus 5 over y. So that would be your final solution for that. X plus, I put y, but that should be a 3. So x plus 5 all over 3. So again, these vary. So the solving part's not always going to be identical because every equation is different. But the basic step is replace f of x with y, switch x and y, and solve for y. And as you're going, check along the way to make sure that you got it. So the inverse functions and the original functions are going to be symmetric, and they're going to always be symmetric over the line y equals x. So if you graph the diagonal line y equals x, you will notice that these two graphs basically are mirror images over each other, or that line.